variable expression, and it involves the function and some sort of inverse, right? But it is a bit different than the question that we worked the other day, that has the sine and sine inverse, or cosine inverse of the cosine. You see that they're actually mixing two different kind of functions. But it turns out that they are not as bad. So what happens is we're thinking, so in general, if we're expecting an angle as an output of an inverse trig, right? So inverse tan, inverse cosine, inverse sine, they're nothing but just angles, right? But now do you see that the problem is just trying to tell us an angle, but in such a non-intuitive way. So tangent inverse of a 3/4 is an angle, but if you don't call it an angle, and most people didn't realize, and that, you know, that's why you know, they think that maybe this is something pretty complicated. So I'll say that the best way is to force you to look into an angle that could replace this complicated expression, right? Call it theta, and let it be tangent inverse of a 3/4. And that's not even the end. Rewrite that equation to make it look even better, right? So tangent theta must be 3/4, right? That way, you know, oh, we know that angle. We're looking for the angle, but we just know the tangent of that angle is 3/4. And the question is asking us sine of that angle. But we can actually draw a right angle triangle, labeling the sides using the information we get from the tangent theta. If you do have a missing side, figure it out using Pythagorean theorem, right? And once you have the right triangle, you can figure it out all remaining 5 functions, right? Sine theta, cosine theta, right? Even tangent, cotangent, secant, cosecant, right? You can get all of them, okay? And turns out that's it, right? So again, this is a problem that intentionally try to confuse you with a complicated way of specifying an angle using the inverse trig. Okay, and you shouldn't really let the problem to confuse you. And a way to make sure that you're not confused is to actually take the complicated thing, realize it's nothing but an angle, and please call it as an angle. And this is probably the only letter we have used so far, right? It's a Greek letter, of course, you know, but that's pretty much now the only letter we've used for any angle. Okay. But sometimes you might have to deal with something very similar, but you have sine inverse of, you know, a negative thing. So everything works out the same way, except that people get you know, a little bit stressed out since they see sine theta is -1/2, right? So the way you can still work around with this kind of negative ratio is to pretend you don't see that negative sign and still do what you had to do, right? By drawing the right triangle, labeling the sides, and figure it out the problem cosine of the angle theta must be from this right triangle radical 3/2, right? But you know, if you ignore something mathematically, it will come back to you, right, at the end. So you need to figure it out. Should you get that negative sign for the cosine or not? You may not need that negative sign, right? But you need to figure it out. The way it works is to recall the angle theta comes from the inverse sine. That means it must be in the range of the inverse sine, right? The range of the inverse sine is from -π/2 to π/2. Therefore, if you can picture what it looks like, it's an angle that starts from 0, right? Turning in a clockwise direction, sweeping out 90 degrees, right? To get to π/2, right? It's just the first quadrant, or you sweeping out an angle in the other way around to get -π/2. It's just first and the fourth quadrant. But sine theta must be negative, which means that the angle has to be in the fourth quadrant, right? For the sine to be negative. But in the same quadrant, right? The fourth quadrant. Cosine has to be positive. And therefore, you realize, in this case, you are still getting a positive cosine, right? Even if you have a negative sine, but cosine is going to be negative. So cosine is going to be positive. But sometimes you do need to keep that negative sign for those trig functions. For example, if I'm asking you the tangent of the same angle, and you realize if the angle we already figured out has to be in the fourth quadrant, but the tangent must be negative in the fourth quadrant. So you better keep that negative sign. Okay? And you see that it's indeed because you have a positive cosine and a negative sine. If you do sine of a cosine, you get a negative tangent. Okay. So this is definitely going to be a FRQ, right? And at least that's what I did, for my first draft, right? I already sent it to the department for them to review. So I did pick questions like that as an FRQ, see if they like it. But I think that this is just one of the best problems, not very overwhelming. But as long as you know how to get started, right? Show me the first step that I know that you're on the right track. And everyone know how to get the right answer, right? Using a calculator. That means you should get at least a point from the answer, 1 or 2 points from how you set it up, then 2 more points from the work to show me that you can either draw the dry triangle, label the sides correctly, and identify the ratio for whatever function you're looking for, right? So I can easily award you for 5 points, right? And also, there's not too many things that you couldn't show me just based on your understanding of the basic tricks, right? Anyway, so now I'm just trying to help you to recall, this kind of technique. And now I want you to try a few problems from the test review packet. All right, so those 4 questions. And I notice that in the instruction, they say use a sketch. And the kind of sketch they mean by is the right angle triangle. So let me give you 8 minutes, like I did, with the previous 2 classes. So 2 minutes for each question, not too long, but definitely a bit longer than you expect for a question like that. Because if you were to use the calculator, you would have got, all the answers within a minute, I guess, right? But that's going to be FRQ, right? So first get the answer correctly, right? Then pick, as many questions from them. Let's say if you like 47, because this cosecant looks pretty challenging, right? Work it out the right way. Think about what you're going to show me, in writing, right? In a test. All right, let's put a timer here. 8 minutes countdown. All right, so it's about 8 minutes already. All right, so let me show you the answers. So at least you know, make sure that you're getting it right from the calculator. Then like I said, they are most likely to be FRQs, right? So let's make sure that you guys are able to show the correct work. So my 1 and 2 p.m. classes, they for something they both pick, you know, 45 and 47, right? So let me go over those two questions for you as well. But you know, feel free to let me know if you want me to go over 42 or 46. Right? But I think that they picked 47 for a reason, right? I guess it's the secant, cosecant, tangent stuff, right? 45 probably is cotangent, right? Anyway, let's take a look at 45 first. So we'll do the same exact thing as before. So we find the sine inverse of a radical 2/2, like some kind of trouble, right? So let's go ahead and just call it theta, because you are getting an angle theta from a inverse trig, right? So theta equals sine inverse radical 2/2, right? And also, once you write this down, don't hesitate. Please go ahead and rewrite it as sine theta equals radical 2/2. So I hope that all of a sudden feel like that this is now something that you're so used to, right? Not to mention that maybe some of you already noticed that theta must be a special angle. So we are looking for cotangent of the angle theta, right? Therefore, go ahead and put it down, cotangent theta, right? So given sine theta is radical 2/2, find the cotangent theta. If you know the special angle, which is, by the way, 45 degrees, right, you would have figured out this is 1, but you don't have to. Go ahead and draw the right triangle, right? This is angle theta, right? The opposite must be radical 2. Hypotenuse can be 2, right? And you solve for one of the shorter legs by taking square of the hypotenuse, 2 square, right, minus the square of the radical 2, right? So you figure that the other side will be also radical 2, right? Therefore, it's a isosceles right triangle, right? 45, 45, 90. Therefore, cotangent is adjacent of a hypotenuse. Oh wait, adjacent of an opposite, right? So this is 1. All right, that's 45. Yeah. Anything wrong? Sure. I'll zoom out a little bit. Yeah. Get rid of the. Okay. All right. Now 47. All right, the same process, right? So let's go ahead and yes. Uh, well, I don't want to say it's the only way. But you do have right now. Let's say if I were to grade the student work, right? So I'll give a point for this, a point for that, and a point for the answer. So now I have 2 points left, right? So I can give 2 points for you know, the sketch, because you're gonna have to label them and get the remaining elements figured out, right? So yeah, let's think about that. All right, now let's just quickly do this kind of little trick again with 47. So again, we will quickly identify theta as tangent inverse radical 3/3, and then you go ahead and rewrite it as tangent theta equals radical 3/3. So now you're going to remind yourself you're looking for secant theta, right? But in this right triangle, Angle theta is here. Opposite must be radical 3, right? Hypotenuse is going to be, not hypotenuse. Adjacent must be 3, right? So hypotenuse will be sum of the squares of the 3 and radical 3. All right, so 3 square plus radical 3 square. So it works out as radical 12, or simplify it to be 2 radical 3. Now cosecant, I guess that you guys will be able to tell right away. It's 1 over cosine, 1 over sine. Right, so SOHCAHTOA sine is opposite of a hypotenuse. So it'll be 1 over radical 3 over 2 radical 3, right? Then do the keep change flip, right? So this is 2 radical 3 over radical 3. Radical 3's cancel. So you're left with 2. Okay. That's it. The process is identical. Therefore, remember how to get started, right? With the right answer. It's almost impossible for you to miss, right? The middle part. I saw some hands up. Any questions so far? Oh, yeah. Sure. The flip, right? Yeah, that's fine. Anani? But all I have to say is, don't simply just show me an answer. Okay, there needs to be a word. But like I said, sometimes, maybe I need to justify on my end without letting you know that why am I signing, giving points for certain things, because the bottom line is if the answer is correct, so I'm more towards giving the points as long as I see something is relevant and reasonable, right? Yeah, and I'm, which one? 46, let's take a look. All right, 46 is cosine of a tangent inverse 1/5. 46, right, cosine of tangent inverse of 1/5. Okay. All right, so let's go ahead and set up theta equals tangent inverse of 1/5. And then you reverse it, you say tangent theta is 1/5. Okay, so now you're looking for cosine theta, right? So the right triangle here, the theta here, opposite will be 1, right? And the adjacent will be 5. So hypotenuse is going to be 5 square plus 1 square, right? Which is radical 26. So now cosine must be adjacent of hypotenuse. So it'll be 5 over radical 26. And rationalize the denominator, you get 5 radical 26 over 26. Okay. All right. All right, no problem. Now, let's see if you guys can, yeah, go ahead, John. Go ahead. Well, you want to zoom out to see all the problems? If it will be too small, maybe not. Okay. All right, guys, what about 48? Take a look. Maybe? All right, 48. Think about if it's really that much different from the ones you already figured out, just because you see the X, just because all those options are so complicated, still do the right thing, right? I'll guide you through, 48. So I'll do 49, 50 probably next week. But at least 48, I'm sure that you'll figure it out. What do you do first? You see something that's just overly complicated, right? Tangent inverse of x, whatever. So let me just call it theta. Right? And I can always do that. It doesn't matter whether it's 3/4 here or x or y. So now again, don't hesitate. Rewrite it as. Well, why don't you tell me? If I rewrite it, what does it look like? Tan theta equal to x. Yes. Tan theta equals x. And you know how to label the sides. If I draw a right triangle with angle theta here, what should be the opposite? X. And adjacent must be 1, x over 1, right? Then hypotenuse, I mean, you do have to figure it out using Pythagorean theorem. It will be x squared plus 1, right? So now look, what are you looking for? I'll zoom out a little bit. It's sine of that weird angle, right? So sine theta is opposite over hypotenuse. It will be x over radical x squared plus 1, right? That's it, right? Okay, but here's the problem, right? None of the answers matches the one I figured out, right? Yes. So some say C, right? You guys all see it? Letter C is nothing but you rationalize the denominator. That's all, right? But you see that it doesn't even need the calculator. And that's why I said that there's some problems we could design it in a way. We didn't design it. We can pick it so that you don't find the calculator that useful anymore, right? Yes, Maya. Good question. So now it is because that people are not used to seeing x as a ratio, but is it right to put x over 1, right? So because remember that I keep saying trig is a ratio, right? So let's say tangent. Tangent takes an angle, spits out the ratio. But when you see a number or integer, you probably don't see it as a ratio. Or 2. 2 over 1, right? That's a ratio, okay? Now you see that, I don't have time for you to figure out 49 or 50. But do you see that here? X over radical 2. You know that you're going to label the opposite to be x. Hypotenuse is going to be radical 2. That's it, right? Anyway, now we'll come back to this, when we do the test review. But I do want to get started with 5A. But at least that, the first part, which is definitely going to be something that you already know, and you probably already did something like that back in geometry or even algebra 2, right? So let me first get you a worksheet, not for homework or a quiz. Don't worry. Oh, you got it. Yeah. But don't lose it because we'll finish this, next time. But I'll get you started with one of the problems in it. Yeah. Yeah. I haven't assigned any tests. I haven't assigned any quiz yet. It's just not too much time before the next test. Yeah. Yeah, I'm not a big fan of having quiz. So, yeah, no problem. All right. So now as you can see that there are only 3 learning objectives in 5.8. So we'll deal with the first one today, which is saying that we need to solve the right angle triangle. As you can see on the worksheet, there are a whole bunch of right triangles, right? What do you mean by solving for it? So you're gonna find out all the missing angles and also the sides, right? So some of the triangles has like 1 angle given. Well, you know that every right triangle is gonna have an angle given for sure. That's the right angle, right? So you're looking for both the acute angles and also there might be some missing sides. But it will be so straightforward because you don't need anything else other than something you already know so far. For example, like this, example here, we have a right triangle, and they told us that the angle A is 62.7 degree, and the opposite of that angle is 8.4. So we're missing the angle B, right, and the side B and the C. But I'm sure that you can tell right away angle B is such an easy thing to figure it out, right? Since A and B are complementary angles, right? So angle B will be 90 minus 62.7, right? Use the calculator. So you get 27.3 degree, right? Pretty easy. Well, I'll write the 90 a bit better. But now we have to deal with the side B, which is the adjacent of a 62.7, and C is the hypotenuse. When you're thinking about, we have the opposite already. If I want to find out the adjacent, I mean, that's going to be tangent, right? Tangent is the one that relates the opposite and adjacent. So if you now write down tangent 62.7, which must be the opposite, 8.4, divided by the side B, and looking for the B. Now I know that sometimes people might mess up the order of a division. If you want to be safe, put tangent over 1, then do cross multiplication, right? So you're going to get B times tangent 62.7 equals 8.4. Yes, Max? It's better if they told you things in degree. Yeah, so that's why, you want to, yeah, that's a good question to ask yourself. Hey, should I use degree or radians? I would say most likely it will be radians, but if you already see the degree symbol there, then you know that switch to degree, right? Now, solving for the B by dividing out the tangent 62.7, right? So can you guys do that for me? 8.4 divided by 62.7, tangent 62.7 degrees, not radians. And tell me how much is it? Oops. 4. Okay, let's say maybe 4.3, right? Now, when it comes to rounding, I think that you keep 1 or 2 decimal places will be good enough for our tests. Now one more, right? So the hypotenuse, well, that's, even easier. So you're gonna go with the Pythagorean theorem, right? A squared plus B squared, right? So be 8.4 squared plus 4.3 squared, take the square root, and whatever it is, okay? Pretty easy, right? And also this could be very likely FRQ, right? See how nice it is to assign, like a point every once in a while, right? So let's say that's a point for figuring out the angle, right? That's a point for set up the equation for solving for the B. Solving for the B, get another point or 2, right? Find out the C, get another point or 2, something like that, right? 5 points, right? Right. Now, why don't you guys take a look at number 4 on the worksheet I just gave you. All right, give you a couple of minutes to give it a try. And once you've done it, we'll call it a day. So number 4, you need to find, all the missing stuff. Because in that question, I didn't tell you any angles except for that 90 degree. You find out both the acute angles, and I think there's a missing side, the hypotenuse. Well, technically speaking, you're done for the week. I don't know. Unless you have some work to do. See, how can they say that? The world's finest chocolate. And have you guys been to Sarasota? And there's a beach, they say the world's best beach. They did some survey or they study that it's the best beach on earth. Oh. Yeah, you know, if you go around and see that there are a lot of things gonna, anyway. Now, if you got a bit confused, like, you know, how can we get the angle if neither of the two acute angles were given? Well, think about what we have been doing. We're looking at, let's say if you want to find out what the angle 8 is, you're looking at its opposite and adjacent. Then I hope that you quickly think about, you know what, if I write down tangent of the angle A, which must be 5.1 over 8.2, but hey, isn't that what we liked? But this time it doesn't give me anything, right? Since the tangent takes the angle and strips out the ratio. I don't want the ratio anymore. I want the angle, right? So that turns out that you will appreciate the inverse function because inverse tangent is going to tell you what the angle is, right? So you put angle 8 is nothing but tangent inverse of that ratio you want, okay? And if you put that in the calculator in the right way, then if it's in degree, it will be about 32 degrees. Okay. So now the rest of the work, it will be super easy, right? Because letter C is the complementary angle, 90 minus 32, right? That will be 58. And what else? Okay, the remaining side, CA or AC, right? That's the notation for segment. AC is the square root of sum of the squares. So it'll be 5.1 square plus 8.2 square, and you can figure out whatever it is. Okay.